Perfect. Welcome, folks, to the fourth and final session today around launching the Aleph Edge end user community. Those unable to attend our earlier sessions, we do have recordings that will be available both on the swap card platform that you use to enter the session, as well as on the Aleph Edge YouTube channel. On this final session, I'd like to introduce Michael Eaton from Jacksonville Energy Authority alongside Robert Raesemann, also from JEA, who will be presenting a use case on energy and their work with the Fledge project, which is one of the projects hosted by LF Edge and the Linux Foundation. Without further ado, I'll hand it over to Michael and Robert to get things started.
Okay. Thank you very much. Greetings, everyone. My name is Michael Eaton, and my counterpart, Rob Raesemann, will be presenting to you today our journey with Industrial IoT, some proof of concept work that we launched about a year ago, maybe a little bit over a year ago now, and we've done multiple use cases, and we just want to share some of the findings and experiences from that work and where we're going next with it. So with that, go ahead, Rob. So a little bit about JEA. We are a municipal utility located in Northeast Florida. We're the 8th largest in the country. We serve 3 counties, and the services we provide include electric, water, and wastewater utilities as the main utility services to our customers and community. We serve with those 3 services, primarily serve about 1 million customers in total. Includes residential, commercial, and industrial customers. We have about 2,000 employees total. And from a standpoint of a little bit of lay of the land with our utilities, we have about, from a design peak of energy megawatts, we're designed for about 3,400 megawatts design peak system load. And then on the water side, we've got on water and wastewater plants, treatment plants, we've got over 40 plants in total in those 3 counties. In addition to that, we have over 1,200 wastewater pump stations that we have to maintain these assets in our service territory also. So it's very important from an asset management perspective, all these assets. Okay. So yeah, a little bit about myself, background. And what you'll notice here, both Rob and myself have engineering background, as well as we grew up in the IT industry, over 20 years of experience, and it really helped us, I would say, in really bridging the 2 groups together between operational technology and the traditional information technology groups. It's really been an asset in that regard. And certainly with Industrial IoT now coming along, it's just adding to what we can do and capabilities we can provide for these clients and companies. Next slide. So as I said, I brought Rob in. Go back one, Rob. Just I brought him in also with his experience, but he also has not only utility experience, but he has a broad experience in other OT industries like manufacturing and pharmaceuticals and so forth. So I really wanted that insight and perspective also in working on our projects that we had. In addition to that, I'd say that he brings to the team development skills that we really needed to help us with this proof of concept work. Okay. So as I was saying, the utility industry has been and still is a very asset intensive industry, but our business models are rapidly changing and evolving as we speak, and that's primarily having to do with several factors at hand. One of which is the fact that our revenue growth has flattened out. And so a lot of that is due to there's more and more energy efficient consumer products like light bulbs, as well as appliances, things like that have really impacted our revenue growth. In addition to that, having stagnant revenue growth, the notion of pressures from external pressures and so forth, with becoming more using more renewable energy and being located, of course, in the Southeast and Florida and so forth. Our distributed energy resources are primarily photovoltaic or solar solar farms and so forth like that. And so that's going to impact our grid that's changing and evolving. How we need to do short-term planning of the grid now. It's not just a long-term plan. We've got to do short-term analysis for scenario planning. In addition to that, our customers expect more interaction with them. So we've got to provide capabilities, new capabilities to really interact with our customers, and behind the meter as well as outside the meter. And I would say that our customers expect us to provide high reliable services at a cost efficient, very cost efficient way. So that's very important. We got all these things that are evolving our business models as we speak. Okay. And so typically, the utilities typically are not, do not really leverage bleeding edge technologies. Usually, it's after it's been developed a little bit and so forth. But quite unusual. JEA, I think we've and even JEA, we're a municipal utility. We actually have embraced technology over the years, going back to the late 90s when JEA acquired the water and wastewater utility from the city of Jacksonville. We basically had these disparate SCADA systems, OT technology and SCADA systems that were siloed. No visibility into them or anything like that, as well as our electric plants and so forth. So we had a need to centralize and to share that data across the enterprise to provide visibility to everybody in the enterprise about what's going on, how the plant processes in real time. And so going back to there, we really embraced technology and provided some IT/OT integrations back, ever since the late 90s. And I think that's a success and the strength that JEA has. And now, we're just building onto that with the industrial IoT stuff. But it was important to get that infrastructure in place because we implemented the centralized data historian, like I said, to share data to the enterprise and provide that transparency and visibility across all these plants and and how they're operating them. But that also led us to be able to do and move into, and this is back in the early 2000s, move into process control optimization using neural net technology, AI and machine learning to do optimization stuff. We had some projects where we actually optimized the boiler at our generating plant. We also use this data, that infrastructure that we built with the centralized data historian to optimize our well field, our pump well field and the water plant, as well as optimizing our water operations. So we were sort of doing stuff back then that sort of taken off, as you guys know today. Next. So why industrial IoT for us? As I said, we've got a good pedigree with our IT/OT integration and done some really good work, good foundational stuff. But now with the advent of more compute, on these small Raspberry Pis, and sensors now have more compute and intelligence at a very economical cost. We can now put these things out there and provide more visibility on our assets. And it really is now driving. It's not just about the operations of these assets from a systems perspective or the process controls, but really now we're getting a demand for the asset management aspect of it to allow them to be more proactive in monitoring, having visibility of the performance of the asset and to be able to avoid equipment failures and so forth, to be proactive. So, in the advent of having these, being able to put inexpensive compute at the edge, now we've increased, we're exponentially going to increase our data streams over time. We're going to have more and more data sources. So it's not just the SCADA system as a source, but now we're going to have lots of thousands of different data streams, and we're increasing the volume of data. And so really the industrial IoT augments that foundation that we had already with the SCADA IT and OT integration that we already had. This really just augments it. Doesn't replace it, but it augments it. Because the SCADA stuff, typically they're limited, there's limitations to it with, it's sort of behind the times in terms of modernization, but also they have stricter, guidelines with regulatory stuff, if it's SIP type things and things like that. So there's limitations and constraints with that. So we needed a flexible platform to bring in these many more data streams and volumes of data. And like I said, it opened up to more than just process control and operations of consumers. Now we have asset management, consumers. We have, like I said, short-term planning now from a grid perspective and system analysis that are consumers that need this data. So it opens up a lot more capabilities and business models for our utility. Okay. Some of the things that we've encountered with doing this work over the years or so, I would say we had challenges with some of these vendors, sensor vendors that provide these sensors. A lot of them want you, or they only offer a package deal where you have to buy their proprietary, not only you buy the sensor, but you got to buy the whole package, which is a proprietary communications back to their SaaS hosted, server where they put the data or persist the data. Well, that's a challenge to us because, as I mentioned, we have a really good SCADA, centralized SCADA system here for alarming and stuff like that. And the operations, folks don't want to have, a dozen different, web portals to different cloud SaaS, just to see some sensor data from different types of sensors. So we really needed a way to integrate, integrate from these cloud hosted data repositories, if you will, to our repositories on premise. And so those are some of the challenges that we're dealing with, and we've got some design patterns to deal with that. But those are just sharing some of the things we're dealing with these sensor manufacturers that have their own business models and so forth. I'd say the other challenges are, once we get this data into our repositories, is how do we associate this data with other data in our utility? The key is that we want to make it simple as possible for our users to do advanced analytics. And because of our background, as I mentioned before, in process controls and optimization and analytics that we did years ago in the early 2000s, I understand that you need to have not only clean data and things like that, but to be able to associate that data with other data so that you can be very effective and efficient with your analytics. We want, again, our users to be spending more time doing the analytics and less time wrangling the data. So it's key that we associate this data together, this enterprise data together, and so forth, and let them know what's available to use. Okay. And so this is, again, reiterating some of the advanced use cases that we're tackling right now. There's a lot of good stuff, that opportunities in this condition-based maintenance for asset maintenance, both on the water and the wastewater and the electric side. We've got multiple use cases, whether it's using infrared cameras or temperature telemetry stuff. We've got a really good variation of use cases. So it's exciting stuff for us. In addition to that is, we're breaking these data silos from these disparate systems. I mentioned we have a data historian, and we've got these other, repositories. Well, we're now, again, associating and linking that data so that make it highly effective and efficient for analytics. And I'll turn it over to my counterpart, Rob, to continue.
Okay, so after watching the RTE presentation prior to this, I realized their scope of what they're doing is actually touching the industrial control systems, and ours is kind of fundamentally different in that, we've reached limitations with doing this traditional IT/OT integration using the existing control systems, but our approach right now is to leave the existing control systems alone and augment them with our IoT systems. So in the next few slides, I'm going to kind of outline why we're doing that. But of course, we've got these existing control systems, that are focused on reliably and safely operating a mission critical process. So, in the utility, you can stand in a room with a bunch of computers that are controlling the electricity to, 1 million people. And so obviously we don't want to mess with those. They're heavily regulated. Cybersecurity's a big thing, and change management's a big thing. They're very conservative in their operation. They're slow to upgrade and change. They want to stick with trusted and true. And these are also, they're expensive and proprietary systems, often have tag-based, licensing models. So when we look at the IoT and we want to add a bunch of things to it, we can kind of drive their costs astronomically high in no time. And we have to deal with a lot of the older legacy protocols and, the things where your tags are mapped to a numerical address and then it's converted into a tag later in a different database, and you scale it and all that kind of stuff that we would like to get away with or get away from. And, support of these things is pretty manpower intensive. This is in stark contrast to the IoT stuff where, the hardware's, open hardware and software, faster, cheaper, more efficient, more modern protocols, where you're doing things like JSON, and your values and your tags are all melded together from the beginning. Things are in the final engineering units. You're not fumbling, numerical addresses with tags and all that other stuff. We're also going to have, separate networks. They're going to be focused on data collection. They're going to be reliable, but they don't have to be as mission critical as the control protocol, as the traditional control systems have been. Because we're doing read only or reading sensors and not actuating anything. The regulatory burden is reduced, and we can streamline things like change management, and we can be faster to add things and make changes to these networks than we could ever be on the traditional OT side. We also want to make, we also want to open the gateway to the more distributed computing, edge processing. The traditional control systems are very much, like pull your sensors, get your information, centrally make the decisions, and then push the results out to the network again. So we want to take advantage of, newer technologies faster and everything else. And of course, we need to do this in a way that's scalable. We're not looking at small control systems that are all little silos. We're looking at doing this, at an enterprise scale, where we come up with a pattern that supports, multiple use cases. The specific use case, the first one that we've really been able to spend some time and money on is monitoring these large transformers at the electric substations. And we've got a picture over here on the left of this slide of a transformer that exploded. There was an undetected problem. The control system that controls this, the SCADA system, doesn't monitor things like dissolved gases and from the oil and detect arcing. It's not looking at whether or not fans are working and things like that. It's opening and closing breakers and measuring the amount of current and power that's going through it and all of that. So we have these large assets, and when one of them fails like this, you not only lose whatever redundancy you had at that substation, but it can easily cost over $1 million to haul the old one off. Order a new one. You can't even really get them off the shelf quickly. There's a time span where you're waiting for the replacement, and then of course you have to shut down roads to bring these things in and have expensive cranes and everything else. So this is a great opportunity here for us to try to prevent these types of failures and add some value to the business there. When we look at the old traditional way of doing this, of course, in the old days, we've added sensors and things like that weren't necessarily involved in the operation, but were nice to have for maintenance. And we've been doing that for years in the old IT/OT scenario. But we run into a lot of different things, is that, you want to add a bunch of these sensors. So of course, the control system folks start getting nervous. You're adding a bunch of devices to their system that, don't have anything to do with their core business, which is running the control system. We run into problems where, maybe the device offers us, 100 different pieces of information. The control system folks are happy to take 2 or 3 of them. They don't want to take all 100 of them from all of the devices we're going to be out there. We also have use cases now where we're looking at things like video and stuff like that are, easy to do in IoT, or at least IoT accommodates them better. Traditional control systems, they don't even know what to do with it. And then the big thing too is just, like I said, like we'll have, you'll be sitting in a room where, you could interrupt the power flow to 100 or 1 million customers. We also, walk by steam turbines that have almost 1 million horsepower going through them. So, it pays for people who control those kind of things to be as conservative as possible. There's going to be times of high load and things like that when we're not even allowed to touch anything because you don't want to make a mistake and cause, a power outage or a generation outage when the demand is high. So we've just run into all these things over the years. This is our use case here for the, our new IoT way. And, on the left, we have our traditional SCADA system. We're going to leave that alone. It's on its own network. It's doing its own thing, everything it's always done. On the right side, we have our Fledge network where we're putting our sensors on the transformers. And you can see that on the left side, we've got sensors and actuators. On the right side, we only have sensors. That's at least, initially as we're getting started on this and as we're getting permission to put these things in electric substations, which are, regulated by cybersecurity regulations and everything else. We've explicitly said that we will be hooking these sensors up if they have the capability to control something that isn't even going to be wired in. Now to talk to these sensors, we're using the traditional protocols. So we still have to deal with those traditional protocols, but we're doing that at the south plug-in level of Fledge. So as we talk to the device, we're, converting it to tags and engineering units, right off the bat before we insert the data into the data stream. We were kind of fortunate here that at the electric substations, they already had these Cisco Cat 9000 industrial switches. And Cisco has a platform called IOX for hosting IoT type applications. And so this little switch there has an Intel Xeon processor. It's, pretty powerful little server. And it will run Docker containers. So we've Dockerized the Fledge system, and we're running it in these Cat 9000 switches that were at the substations anyway. So we didn't have to run any additional hardware. So these switches, the south plugins are polling or receiving updates from the sensors, and then we're shooting it up, upstream so more people can get it. This is a more detailed look of, kind of the upstream type stuff. I'll point out that we've kind of got a suite of sensors that we're evaluating. So we've got some things that do things like measure, temperatures and currents and things on the transformers, whether or not fans are operating, stuff like that. And then we also have gas analyzers that are looking for evidence of things like arcing inside the transformer to indicate that, the transformer is having problems and needs maintenance before we have the big explosion. We're also doing things like, monitoring tap changes and things like that, so we can tell how much wear we're getting on those and when they need to be serviced. And then we've also got some infrared cameras for doing, non-touch temperature measurement. Upstream, we're using a North plug-in to shoot data into a Kafka service bus. So Kafka is something new that we're doing, but we're not only shooting the data that we're reading, but also any events that we're generating by looking at the data. And then from there, we're putting it in. We've got a OSI Soft historian that we've had for a long time. We're putting data into that. The Kafka service bus basically allows us to publish to it, and then we can create whatever subscribers we want. And so we're also looking at some other time series databases for less important data that we can put stuff in. And we have things like the camera images where we want to collect the camera images and put them in S3 storage so that we can do things like train models and try and do detection. The eventual scale of this, right now we're rolling this out to the first substation. They're pulling conduit as we speak. But there's about 70 substations. We figure there's going to be about 4 or 5 different sensors that we'll ultimately pick that, we want to put out there. And so we'll probably end up with approximately, 30 sensors per substation and 70 Fledge instances deployed eventually. So, we have to develop things like how we're going to do this, in a templatized manner so that we can roll these things out quickly. And we're looking at things like, Dynamic has the Fogman platform for managing a fleet of these. And then we have things like security and stuff like that that we're also working on. And making sure that the data is encrypted, that the nodes are locked down and all of that. Cisco also has a platform for updating the Docker containers and things like that. So I think, the Cisco platform will be used to deploy Docker containers. Once the Docker containers are running, Fogman will be used to manage the actual Fledge operations there. Our initial experience with Fledge has been, very positive. We got started on this pretty early. So, Michael and I actually had a discussion, was this, how much of this is real and how much of it's vaporware? And of course, at the beginning, we knew that there were things that they intended to do that they hadn't done yet. And I have to say that they've been able to keep ahead of us, that by the time we've been ready to start looking at things like events and filters and all that, that they had implemented them. So, it's been really, pretty easy to set up. Had a little bit of, learning to get up to speed on Docker, the Dockerization of this and building Docker containers so that we could deploy it to the Cisco platform that we wanted to deploy it to. We like the fact too that the plugins, we have the capability, the plugins can be developed in Python or C++. So quick and dirty, you can throw something together in Python and get it working pretty quick. If you run into performance limitations and need to do things like multi-threaded and all of that, you do have the capability or the option of developing the stuff in C++ as well, which obviously is going to give you a lot more flexibility and power at the expense of a little more complexity there. So we have not had to do anything in C++ yet. The stuff that we've kind of developed on our own has been in Python, and that's worked really well. Our challenges, I think like everybody's finding out that the technology is not really the hard part, right? There's almost too many options for things. But, trying to get this into the culture and get people used to it and everything, getting the permission to roll this stuff out into the substation and people being comfortable with it from a security and, also, well, like, why are we doing something different than what we've done in the past? That's been something that we've had to manage. Also, the electric utilities haven't really been huge adopters of open source technology. So, we like the open source for things like Michael said, when you get these off the shelf solutions that vendors offer, we wanted open source so that we could say like, hey, you can support this platform and then you can send us the data and it looks like all of our other data, versus, doing your own thing. One interesting thing is that, the utilities, we've got like, JEA has actually got trouble trucks in Louisiana right now, helping to fix their electric system after the hurricane. So there is a spirit of community community commitment and utilities working together, and so we're hoping that we can be able to use that to help develop the open source community and develop our use cases and stuff like that. But longer term, support, training, things like that, we're just not used, we're used to dealing more with proprietary solutions and companies. And so how we're going to manage that is something that we still need to work out. And then we have things like, cybersecurity and things like that, we don't want to have to operate under the same strict measures that we have to with other, with the control systems, but at the same time, this obviously has to be secure enough. So future use cases, we've got, as Michael mentioned, water and wastewater, electric generation. There's also, renewables and new systems that, JEA is not used to operating and maintaining that they have to. So there's a lot of pent-up demand. So we're hoping that this first, proof of concept works out well, that people see the value of it and then want to roll it out in the other business units as well. We're looking at things like we're looking at the FLIR infrared cameras for doing the touchless temperature monitoring, where we can set up the cameras on different things and, alert us when there's a problem. Vibration monitoring is also a big potential use case. That's something that historically has always required proprietary solutions that, because of the high-speed sampling and the math that had to happen. And these days it's pretty easy to do that stuff on commodity hardware. So we think there's a lot of opportunity there to be able to put vibration monitoring on things that maybe it's not economically viable to do it today because of the expense of the proprietary stuff. And of course, we're looking at the commercial tools, while the open source aspect of it is appealing, and everybody gets started on this thing that, oh, free software. You do realize that as you get into this, that as you become dependent on these solutions, that you're going to need to be able to have somebody on call on Saturday night that you can call if something goes down and you need to get it back up quickly. You don't want to be stuck, by yourself just trying to figure this out. You want somebody who specializes in supporting it. So, that's something else that we'll be, looking into. So that's the presentation.
Perfect. Well, thank you, Mike and Rob. Any questions? And if folks have them after, feel free to email info@lfedge, and we'll make sure to connect you with the JEA team. Tom, any comments from your end? I know we do have some of the leadership from the Fledge project on the line as well.
I just want to thank Mike and Rob for making this presentation. We appreciate it a lot.
Perfect. And Jason, do you want to bring this event to a close? Any final comments?
Yeah, no, I echo Tom's comment. Thanks, Mike and Rob, for presenting here. I mean, this is the kind of stuff that really wraps context around what we're doing as a community, and obviously we appreciate your contributions to Fledge and just being involved overall. Thanks to Benoit and Obi, also providing additional insights in the various different markets that we're focused on, energy and oil and gas. For anyone that's viewing this, we welcome you guys to join on in, whether it's with LF Edge overall, or especially these user groups that we're launching. End users providing more context around their use cases are super valuable. And so if you want to dive in, go to lfedge.org. You can click on the user group link. There's some links within there for some existing ones. We're definitely looking to bootstrap some around energy and oil and gas and some other markets. If you'd like to suggest one, email info@lfedge.org, and we can spin something up from there. And yeah, Brett's bringing up some of the links. But I think with that, we'll close it down. All these recordings will be available online on the LF Edge YouTube channel. And again, we appreciate everybody for contributing, and have a good one.
Perfect. Thanks all.